Excellent. Okay, so let's start. A few words about me first. So my name is Eitan Blumin. I'm a Microsoft Data Platform MVP. I work at Madeira Data Solutions. It's a consulting company in Israel. We are the leading consulting company in Israel for the Microsoft Data Platform in general and SQL Server specifically. I've been a senior consultant there since 2010, and nowadays I'm also a team leader there for our managed remote DBA services. You can find me on Twitter, on LinkedIn, on my blog, where I publish all kinds of professional content for SQL Server and stuff that relate to it. Same about the website of Madeira Data Solutions, madeiradata.com. We also have a blog there where the rest of the team also publish stuff there. And also you can find their information about our services. I also co-host the SQL Server Radio podcast together with Guy Glantzer, who is the CEO of Madeira Data Solutions. We have a Hebrew version and also an English version. We release an episode once a month for each of these. The first Sunday of every month for the in Hebrew version, and the second Monday of every month for the English version. You can go ahead and check out the past episodes. We talk about SQL Server and the Microsoft Data Platform in general, news, discussions, and guests, and so on. So today we're going to talk about basically what are we spending money on when it comes to SQL Server, and what we can do about it to reduce our spend wherever we are spending unnecessarily. So what are we actually spending on when it comes to SQL Server? Well, mostly we spend money on the hardware, which means like stuff like storage, memory, CPU, all the metals and silicon stuff, and so those are normally the things that we would think about that we spend money on, such as CPU cores, the memory, the storage. Licensing is also something very important, and depending on the situation and network, the network bandwidth, the traffic, could also impact the money that we spend. This list would perhaps be more correct to look at it this way in terms of where usually our biggest spend comes from. So this is obviously not true to every environment and not to every organization, but this is what we as consultants who consult a lot of customers and lots of organizations, this is what we usually see in the vast majority of cases. So the licensing actually is usually the most expensive component of a SQL Server estate. That includes the licensing on the SQL Server itself, as well as the Windows licensing. The CPU cores usually comes next, and based, especially if you have licensing based on the based on CPU cores, that also factors in. But the CPU cores themselves, as in the machine, the hardware itself, the machine itself, that also comes usually at the top in terms of price, and usually it also comes coupled together with the memory, although not always. And depending on where your servers are, you could also be paying on network bandwidth, especially when it comes to cloud services such as Azure and Amazon. And also, obviously, you pay your storage, although usually storage is the most the least expensive component in this architecture. So I'm going to start with CPU cores first, and then we'll go on and proceed to the rest of these components and see how we can reduce the spend for each of them in our SQL Server estate. So before I tell you how we could save on CPU on save on money spent on CPU cores, first I need to explain something when it comes to SQL Server and CPU cores. So let's assume that we have a SQL Server on a machine with 8 logical CPU cores. SQL Server, when you query from DMVs, from system views in SQL Server, there is no view for CPU cores. There is no dmv.sys CPU or something like that. What we do see is something that is called an SOS scheduler. That's short for SQL OS, as in SQL Operating System Scheduler. And what SQL Server does is assign each scheduler to a logical CPU core, so that whichever work items that arrived, whatever, and when I say work items, that means stuff like that implement the logic in execution plans, for example, or for example, receive connections, handle connections, and so on. All of these things require CPU. And in order to use the CPU, SQL Server uses schedulers. And what a scheduler does is say, okay, I'm like the doorman to the CPU, okay? And they receive a queue of tasks, and they say, okay, now you work, now you stop, now you work, now you stop, now you work, now you stop. That's what a scheduler does. And they each they grant access to the CPU, basically CPU time, to each of these incoming tasks. Okay, next we have like a layer beyond that called NUMA node. A NUMA node, I'm going to explain a bit more soon what it does exactly. But a NUMA node is, let's say, a logical or a physical group of CPU cores. A memory node is a layer beyond that, which basically says it determines a range, let's say a range of memory addresses. Technically, it could mean that, for example, in this example on the screen, you have NUMA 0 and NUMA 1 linked to memory node 0, okay? That means that NUMA 0 and NUMA 1, they get access, they have direct access to the memory address assigned to the first memory node, to memory node 0. And conversely, in NUMA 2 and NUMA 3, they're assigned to NUMA node 1, the second NUMA, and they get direct access to that second memory address, okay? So there could be all different kinds of architecture and topologies of NUMA nodes. There could be like 4 NUMA nodes for 8 cores, like you saw previously. There could be 2 NUMA nodes for 8 cores with 4 cores each, and each assigned to a different memory node. Or there could be 1 memory node for 2 NUMA nodes, or there could be just 1 NUMA node and 1 memory node, and then it's like there is no NUMA architecture here. Okay, so but for our example, we'll look at this variation, and as I said, the meaning of these NUMA nodes architecture is that these CPU cores that are residing in a NUMA node, they get direct and fast access to their respective memory node or set of memory addresses. So NUMA 0 and 1, they get very fast access to this set of memory addresses, and NUMA 2 and 3 get very fast access for the second memory node. In some architectures, it is also possible to have I don't recall what it's called. I think it's called cross-reference or cross-access or something like that. Something with the word cross, where it goes something like this, where it is possible for NUMA nodes to access memory addresses that belong to other memory nodes. However, because of the physical architecture behind, it means that the access to that other memory address space will be slower, much slower than the access to the memory space which is assigned to that NUMA node. Or let's say the memory card that this CPU core is closest to. Okay, that depends on the architecture. As I said, it's not the same in every situation. Sometimes it wouldn't be even possible. Actually, I think it's usually wouldn't be even possible to have this cross access thing. Usually it means that, let's say, these CPU cores, they cannot even see this memory. It's like each half of the CPU cores sees a different half of the memory space in the server. What does this mean for SQL Server? Let's say that for whatever reason, it doesn't matter why at this point, 3 of our CPU cores stop functioning, and therefore their respective SOS scheduler also stop not functioning anymore, and they cannot process tasks. In this case, it means that we have actually just one functional CPU core for this memory node, as opposed to 4 CPU cores working with this memory node 0. Okay, obviously there is a very serious imbalance here. Let's even take it a step further and say, first of all, this means that if we have 2 CPU cores out of 2 CPU cores in this physical NUMA that are not operational. This means that this whole NUMA is not operational. It's not functioning. If the 4th CPU core also stop functioning, that means that we have these 2 CPU nodes, NUMA nodes not functional. And now what happens is that essentially, functionally, this whole memory space is gone. SQL Server can't do anything with it. Now it's like SQL Server is limping with one leg, and it has only half of the server's memory available to it for utilization. So I've seen a lot of these scenarios. It happens quite a lot, especially in large and legacy organizations where they have these monstrosities of servers with huge huge numbers of cores and memory and terabytes of memory and 64 and 96 CPU cores or whatever. But for whatever reason, something doesn't work right, or the licensing isn't correct, and basically all this money spent on this very, very expensive hardware is completely wasted. The SQL Server can't actually use it. So, and then we end up with something like this. Let's say you go to the SQL Server and you open up Task Manager and you see like these CPU cores, they're very noisy, they do stuff, and these 3 cores, they're like sleeping, they're snoring, they're not doing anything. This is a completely realistic situation that could happen when CPU cores are not functioning, or rather, they are not accessible to SQL Server. So there is a query that you can run from the system DMV called sysdmos schedulers, where is online 0 or the status is visible offline, and you would get the list of schedulers or like a logical representation of CPU cores that SQL Server cannot use. Okay. So this schedule ID 255, that's the one that is dedicated to DAC, to Diagnostic Administrative Connection. There is always one scheduler set aside specifically for this. Usually it's not relevant, but the others are definitely worth to check. So that was CPU cores. What about the memory? Sometimes, as I said, when we have no CPU cores accessible to SQL Server within a given NUMA node, which makes it impossible for SQL Server to utilize an entire memory space. What we could see is something that looks like this. We have like the 100% memory space available to, like, physically to the machine, and let's say the red line is where SQL Server is configured for the max memory, but in actuality, it only uses half. Why? Because of this thing, because it cannot see the rest of the memory, because their respective CPU cores are unavailable. And this is completely possible. Speaking of memory, you can, oh, right, sorry, jumped ahead a bit. So you can detect this situation by querying from a system DMV called DMOS sys memory, which has columns available physical memory KB and total physical memory KB. You can use that to check which percentage of the total server memory SQL Server is actually using. And also compare that to the max server memory configured. Okay, so in Madera Data Solutions, we have a GitHub repository called the Madera Toolbox. In it, we have a bunch of scripts, and one of which checks for max memory configuration. And this, it can use. We talked about how there's a situation where SQL Server cannot utilize memory, but what if SQL Server cannot utilize memory because someone configured it that way? That is also a possible use case, not just because of hardware-related issues, but also because of configuration-related mistakes, essentially. For example, I've seen a situation where a server was upgraded, like its size was doubled, for example, and yet SQL Server was not able to utilize this extra space of memory because after the machine was resized or upgraded, no one bothered to change the configuration of the SQL Server instance. So that is also something that is worth monitoring for and checking periodically. And we have a script for that in our toolbox. I'll obviously send provide additional scripts to detect the rest of the scenarios that I describe here. Before I go here, any questions about this?
No questions so far.
Great. Okay. So let's move on. Speaking of stuff that SQL Server cannot do, based on the SQL Server version and edition, you could be limited to a certain number of CPU cores or NUMA nodes or memory size. I also saw situations where an organization upgraded the machine and resized some kind of machine, but they had a standard edition SQL Server, so it could not utilize more than, let's say, 128 gigabytes of RAM, even though they had like twice in that, I think. The SQL Server couldn't use it because of licensing related limitations. So this table here shows you the limitations, the hardware limitations per each version and edition of SQL Server. CPU sockets is that's basically could be represented as a NUMA node. For example, in a server with hyperthreading, so you could have a socket is like a physical slot for the CPU cores, and there could be like maybe one CPU core on it with hyperthreading or without hyperthreading, or maybe two physical CPU cores on the same slot, and that could be like a socket with two cores. SQL Server standard edition is limited to the lesser of 4 CPU sockets, or depending on the version, 16 physical cores or 24 physical cores. And when a machine for SQL Server is being configured, especially a virtual one, where these things can be played with and are very flexible and configurable, you need to be careful with that, because in virtualization, for example, you could let's say one day you go to your system administrator and say, we're setting up a new SQL Server machine. Please create a new VM for me. We need 24 CPU cores. Okay, so that person goes ahead and does their job, and they set up a VM with 24 physical cores, 24 logical cores. But for some reason, SQL Server cannot use half of them. Why? Because the person configured these 24 cores like this. Give me 24 cores in total, distributed across, let's say, help me with the math here. Six, right, across six sockets, each with 2 logical cores. Right? Did I do it right? No, I didn't do it right, Did I? Divide by 6, was it 4? 4, right, sorry. Okay, 4. I'm not in a mood of mathematical equations when I'm presenting. Right, so let's say but you know what, I'm gonna leave it on. So that system administrator, they said, okay, let's configure 6 sockets, each with 4 cores. We have 24 cores, here, take it. But in actuality, SQL Server is limited to only 4 of these sockets. Okay, even though they're virtual, they're still sockets in the eyes of the SQL Server. So SQL Server only sees 4 times 4, only sees 16 cores, and we have 8 cores which are unusable. So this is a virtualization related issue, which is a result of this limitation of per edition, I meant. There are similar limitations in Express and Web Edition. If you have Enterprise Edition, that's not really relevant to you. But if you don't, then it's definitely something that you need to look into. Similarly to before, we have a script in our GitHub called server hardware underutilized. It checks for all kinds of stuff, including how many cores there are in the machine, as opposed to how many cores, CPU cores, the SQL Server is actually able to use. So let's sum up a bit about CPU and memory and possible mistakes or issues that could be. So we have the simplest one is max server memory configuration, where the max server is misconfigured, and therefore SQL Server is not able to use all the memory that the machine can offer. Another one is offline SOS schedulers, which can happen due to licensing issues, and it can happen due to hardware related issues. Or it can also happen due to NUMA configuration issues, as in what's it called, the affinity, CPU affinity configuration. If that is something that was configured, maybe badly configured, that could also cause offline SOS schedulers. And these issues could lead to wasted core-based licensing costs, money that you're paying to Microsoft for cores that you cannot use, or you're paying too much on hardware about CPU cores, but you cannot use because you're not paying enough to Microsoft for licensing. And it can also, in NUMA architectures, it can also cause unused and wasted memory spaces. So how do we resolve it? How do we remediate it? Obviously, we set max server memory to the proper value using and script, for example, that I mentioned earlier. If you cannot resize your machine, or you cannot properly resolve the NUMA related imbalance, you can use the processor affinity mask configuration in your instance to manually specify which CPU cores the SQL Server will use. If you don't do that, SQL Server does this on its own serially, as in, let's say you have a whole bunch of CPU cores here. SQL Server, it goes one by one serially, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. But if, for example, it assigned based on licensing, it saw that it was able to, let's say, use 6 cores. Okay, so it's using all of these, but all of these are unused. And because all of these belong to the second NUMA node, this whole NUMA node becomes unused. So SQL Server, unfortunately, isn't smart enough to evenly distribute the CPU cores that it can use across NUMA nodes. So you would have to do that manually. If you have, like I mentioned earlier, virtualization level processor or socket settings, they need to match the SQL Server license limits. This is for an example of how it looks like in VMware. I think it's called vSphere, right? This program, this administration program. And this is how it looks like when you configure the number of virtual sockets, the number of cores per socket, okay? And then it calculates the total number of cores. In other programs, it could be like, it's like a game of 2 variables and in a 3 variable equation, or rather 2 parameters in a 3 variable equation. So usually you would see some kind of variation of these 3 settings, but only 2 of them will be configured because the third one is dependent on the other 2. So it could be like this, or maybe the total number of cores is configurable and the number of virtual sockets, but this one, the number of cores per socket will be automatically calculated, or the other way around, some other combination. And obviously, you should also consider maybe in order to utilize your hardware fully, maybe you should upgrade your license. Or maybe you should downgrade your server to match your existing license limits so that you won't waste money on the hardware. Now, let's talk about storage. Let's say we have a situation where we had a certain amount of storage, and then its utilization rises higher and higher because SQL Server tends to save data for some reason. And then after that, some kind of operation happened which could be in any one of these, that ended up in freeing up a lot of storage. Now, in this example here in this graph, what we see is this dark blue is the used space within the space disk allocation of a given file in SQL Server, right? Some kind of database file. And this bright blue color is the allocated unused space within the file. So let's say the file grew, accumulated data, and then the data was deleted or compressed maybe, and then but the data file was not shrunk after that. So all of these unused space was not deallocated back to the operating system. And now maybe you have a huge disk, most of which is not actually in use. So this could happen maybe after deletions of a lot of data, maybe due to archiving, maybe migrating the data from one database to another, or maybe doing some kind of consolidation, or as part of an expand and contract operation. For those of you who don't know what an expand and contract operation is, it's when you deploy some kind of change to your database, where in order to minimize downtime during the change, you don't, let's say, you don't overwrite existing data. You only add new data alongside it, and only when you're certain that this new set of data, this new structure works okay, that's when you contract. You remove the older data. For example, maybe you add a new column, which is meant to replace another column. So you expand, you add the new column, it works okay, and then you contract, you remove the old column. But what in actuality happens is that you increased your data utilization and then you decreased it. So that's kind of could look like something like this. Or maybe you compressed your tables and simply SQL Server now needs less space, to save the same amount of data. So in SQL Server, we have these. We have sys database files, this DMV, obviously, which is a list of the database files. We also have master files, which is at the instance level. And we have DMOS volume stats, which is a system function that receives a database ID and a file ID. And it gets you a metadata about the disk, the volume where this file resides, such as, where is it? Oh, there it is. Total bytes and available bytes, right? So you can use that to know what is the size of your files, what is the total size of the disk and the available bytes within it. But if you also use this function, file property and space used on a file, you could also calculate how much for each file, how much if each file has unused space. Okay. So it's important to pay attention. This function file property is dependent on the context of the database within which you execute it. So you have to execute it within the context of each database that you want to check. Okay. So if you have, let's say, a file with a lot of unused space, you can add that space to the available bytes in the volume, in the disk where it resides. Where do we have it? For example, this, okay? The total of unused space and the disk-free space within the volume. And then you get the total unused space, which also includes the allocated space by SQL Server, but which is not used. So it is something that will give you more visibility into how much of your storage is actually used or unused, as opposed to, for example, opening File Explorer in Windows and taking a look at how much free space is in the disk. And this is also one of the checks that are being checked in the script that I mentioned earlier, server hardware underutilized. This situation is also being checked for each database in that script. Is there any question? I thought I heard something.
Nope, no questions as of yet. Doing a great job, I think.
Excellent. Okay. So how do we resolve these situations where we have this amount of unused space? Where obviously we should shrink files where we can, but it's important to do that carefully and not do it recklessly. I think it's quite common knowledge nowadays that shrinking files in SQL Server is a bad thing. But with that being said, there are situations where you removed a lot of data which you do not expect to come back, basically. In other words, you don't expect the file after you shrink it to auto grow again because the data started accumulating again significantly. So you should shrink files where you can, carefully, obviously. And when I say carefully, is I linked here a blog post on my site where I explain how to troubleshoot long-running shrink operations, which is something that could happen due to all kinds of use cases. And in short, where is it? No, that's not what I. Yeah, this is what I'm looking for. In short, it's your safest bet, let's say, is to shrink your file using smaller chunks or smaller intervals. So there's a script here for you to do it. Very easy to configure. You can specify the name of the database if it's not the one you're currently in, and the name of the file and the targets, let's say, maximum target size that you want to reduce your file to. So it's either based on that or based on minimum percent that you want to have free, like unused in your file. And this script will do it for you. It will do it by chunks using intervals as specified here. And that could be your safest bet. Sometimes, even in this form, the shrink could take a very long time due to all kinds of edge cases, such as heaps or partitioned heaps or files with a lot of lob data, large objects, and so on. I did a lot of stuff here. I will not go into it right now because it's beyond the scope, but you can find the link here, okay? And the slide will be provided for download, right? Right, Kevin?
Absolutely.
Of course. So sometimes it could also be possible that different database files would reside on different disks, right? And sometimes, let's say, once upon a time, one of those files was very large and it justified its own disk. But then, for whatever reason, the data was deleted or migrated or archived or compressed. And now most of the disk is not used. But even if you shrink the file, you will still have to pay for your big ass disk because it's the only file there. So you could consider maybe consolidating your files and placing more of them on the same disk so that you completely get rid of the rest of the disk that you don't really need. Obviously, you should do that carefully because it obviously means downtime. So do that carefully and mindfully, in terms of production and availability and so on. Let's say we have a different kind of issue. Let's say we have overutilized storage, we have too much data. I'm not talking about unused space that we don't know about. Maybe we do. I'm talking about the other side of the spectrum. Like we have too much data. That is obviously also possible. In some cases, your production environment may not really need that all of that data stored in the same place. In some cases, you could find tables with very old data that your software, your system doesn't actually need. Maybe it can be deleted entirely, or maybe it could be archived and moved somewhere else where the storage is cheaper. Maybe you could apply data compression where possible. I have in my blog post, in my blog, a post about something I call the ultimate compression savings estimation script for an entire database, which is the script I worked a lot of time on. It is an amalgamation of all the compression savings estimation scripts that I could find on the internet. It has all of the functionality that you can think of. It calculates the compression savings for all tables based on a set of parameters, and it gives you the recommendation for each table and for each index what kind of compression would be best for it. Maybe row, maybe page, maybe none at all. It gives you that information, as well as the remediation command, as in the alter table or alter index command themselves. Okay, it's one of my most useful scripts that I ever created. I'm very proud of it, and I'm sure you will find a lot of use for it. And go ahead and use it. Obviously, be careful in productions, in heavy production environments, because it could sometimes cause a heavy load on the server. But I trust you'll do the right thing with it. And sometimes it can give you insights that you never thought about compressing certain tables. Right. Similarly, as I said previously about consolidating files to the same disk. So in this case, what I'm talking about is like, for example, let's say you have multiple databases or spread across multiple volumes, and each file more or less fills up its respective disk, right? In some cases, where the cost of disks is non-linear in terms of cost per gigabyte, and what I mean by that is that the more the bigger the disk, the less you pay per gigabyte, right? In these cases, you should consider maybe consolidating your files instead of having being spread across multiple smaller disks. Maybe place all of them in one big disk, which would be cheaper per gigabyte. And in some cases, especially in cloud providers, maybe it could even be faster, because usually speed of disks is proportional to their size in cloud providers. Okay, so that is also something that is very interesting to think about, because maybe you have multiple small disks. Each of them is very limited in terms of speed. But if you place all of them together, you could have maybe even you could get higher throughput for your buck. Obviously, it's not always true. You need to look into that. It depends on a lot of factors, but it's definitely worth considering. Sometimes, instead of dealing with all of that effort that I just mentioned, it could be cheaper to just add storage, because the human effort sometimes that is required to implement steps like this, like let's say implementing a complicated archiving process, or having to deal with complicated downtime in order to consolidate files and move them around. That would require human effort and human hours, and that is also money being spent. Human time costs money, and sometimes the effort required to implement these remediations would be higher than simply adding more storage, where storage is obviously cheap enough. That is also something important to consider, instead of um, insisting on doing something. It's insisting on doing some complicated migration work or whatever. Sometimes, you know what? Just let it be. It will be just cheaper and easier and safer to just add a few 100 GB, and it will be like pennies for that organization, as opposed to the time you would have to spend as a DBA, your work time, in order to do the other thing. Obviously, it depends on the business, on the organization, on the policies. It could depend on a whole lot of factors, but these are important considerations. Let's talk about, right.
So
Sorry,
before you move on there, Eitan, we do have a question.
go ahead.
Do these underutilization and overutilization issues only apply to on-prem, or do they also apply to Azure as well, or AWS as it could be?
They apply to everything, on-prem and cloud. It's relevant to everything.
Awesome, thank you. That's the only question.
Cool. Speaking of licensing, in case you have an enterprise edition SQL Server, which costs a whole lot of money, you need to ask yourself, why do you have that? If your answer is because there is a feature there that I need, then you need to ask yourself if that feature is not something that exists in a newer version of SQL Server Standard Edition. For example, in SQL Server 2016 Service Pack 1, they added a bunch of features that until then were only available in Enterprise Edition. So that includes table partitioning, data compression, column store indexes, in-memory OLTP, and a few more. There's a link here to, Little Kendra's blog post about it, with some more information. Sorry. And SQL Server 2019, they added a few more features that also were Enterprise Edition until then, such as TDE, Transport Data Encryption, is now in Standard Edition, starting with SQL Server 2019. So in some cases, you could consider maybe upgrading your SQL Server version. Let's say you have SQL Server 2014 or 2012 or 2008, God forbid. Maybe it's worth considering upgrading your SQL Server version, but downgrading your edition to standard in order to save money, but still enjoy the same features that are important to your environment. Again, as I said before, it depends. Okay, it depends on what your organization needs from your enterprise edition. If, for example, your enterprise edition is needed because, let's say, you have availability groups with multiple databases and you gotta have that, or you need to have online index rebuilds, or you need to have a resource governor, or any one of the other features that are only available in Enterprise Edition, that, yeah, sure, stay there. That's, you're right. But if not, then again, this is worth consideration. Speaking of licensing again and considerations, let's say you have a high availability disaster recovery environment. You should know that if you have SA, software assurance, with Microsoft, this thing here, the passive instance is free in terms of licensing, and that is very important to know about, especially if you have, as I said, software assurance and let's say enterprise edition. That is a lot of money being wasted if your AJDR topology has a passive instance. And when I say passive, it means that it is not readable and it's not being accessed for production except when you fail over to it, and then the first one becomes the passive one. Okay. Again, on licensing, this time in Azure. Okay. So in Azure, there's all kinds of stuff that we can do to reduce our spend on licensing. One of which is we need to pay attention to our development and test environments, because there are special prices for that, significantly reduced prices for subscriptions, entire Azure subscriptions that are designated as dev test subscriptions. They could be a lot of significantly cheaper than using a regular, let's say, pay-as-you-go subscription. Right. And there is also a hybrid benefit, which is when you have a license in your organization that was purchased sometime in the past from Microsoft that was used, for example, for an on-prem environment, and then you migrate it to the cloud, and you just need to mark a checkbox. That is all. Just a checkbox in Azure when you configure your machine, and that says enable Azure hybrid benefit, and your cost will be more or less cut in half, because the licensing component in your Azure spend is usually like half, almost or almost half of the cost of the machine in terms of cost per core, and that is relevant again to both the SQL Server as well as the Windows itself. Okay, there is hybrid benefit separately for SQL Server and hybrid benefits separately for Windows Server. So you need to pay attention if and check if your organization maybe has such a license in its care. You don't need to pay again for it if you moved to Azure. There's also something called reserved instances, which is kind of like saying to Microsoft that, you know what, this resource that I have, this VM, this SQL Server, I say that I'm going to use it for the next 3 years at least. And if you do that, you say that, you just pay those, or maybe you don't necessarily pay in advance, but you could also pay yearly or pay monthly, but you reserve that let's say that size, that level of, I don't know how to call it, like let's say it like that. When you create a reserved instance, you specify the size of the resource that you want to reserve. Let's say you want to reserve a virtual machine of 4 CPU cores for the next 3 years. And the more you reserve ahead, the bigger the discount that you get for this reservation. Now, the interesting thing about this is, first of all, as I said, the longer you take the reservation, the bigger the discount. Okay, so one should ask themselves, okay, let's say that I create a reservation for 3 years, but I cancel that reservation earlier. Maybe because I don't need that server anymore, maybe because I upgraded it, maybe because I migrated to a different cloud provider or whatever. What happens then? So Microsoft says like this. First of all, if you want to upgrade your, let's say, VM, to a bigger size, you can actually upgrade your reserved instance without additional cost, or I should say without paying a fine. Without paying a fine for the resizing of the reserved instance. You just add the difference, just the difference, okay, to the reserved instance cost that you already paid, only the difference, and that's it. You don't pay a fine, you don't pay more than you need. It's like you always had that size or something, but I mean not really, but something like that, okay? That's one. Two, what if you do have to cancel your reserved instance? So what Microsoft says is that you have to pay a fine of 12% of the remainder of the cost of the reserved instance. Of the remainder. 12% of the remainder. In rough calculations, that means that if you reserved an instance for 3 years, it becomes cost effective within 7 months. Okay? I'm going to say it again. If you reserve an instance for 3 years, it becomes cost effective within 7 months. Even if you cancel the reservation and are forced to pay the fine of 12% of remainder, you already saved more money than you would have paid if you reserved for, let's say, 1 year. Okay? So what I'm trying to say is always reserve for as long as possible. Okay? Because the implications are that there are essentially no downsides to it. Okay? If you can reserve an instance, if you have a matching resource size, there is no reason not to do it. Okay? I should add one more thing. Rumors have it that this 12% fine that I mentioned is more like a recommendation for Microsoft. In actuality, Microsoft doesn't seem to even collect this fine. Now, I don't want to, promise anything, but these are what rumors say, that Microsoft don't even bother collecting these 12%. Okay, it's kind of funny. But yeah, it's important to know reserved instances are really great. Unfortunately, for Azure subscriptions that are via what's it called, the CSP, Cloud Service Provider, Cloud Solutions Provider. If you have a CSP, if you purchased your Azure subscription using a CSP, unfortunately for you, reserved instances are not supported. It's a big bummer, but it's a limitation of the CSP contract with Microsoft. Okay, so you should know that. As I said earlier, we have a bunch of scripts, very useful scripts in our GitHub repository, including the ones I mentioned earlier. Also, we have ones that I didn't mention. We have a script to detect imbalance, NUMA node imbalance, which is where one or more NUMA nodes are, what's the word I'm looking for? Are not balanced, like they have more load or more CPU cores, significantly more compared to other nodes. That could be very useful for detecting all kinds of situations in your server. If you have a situation where SQL Server cannot use all of the CPU cores and you have multiple NUMA nodes, there's a script here that automatically spreads them evenly amongst the NUMA nodes, which is something the SQL Server, I don't know why, it doesn't do on its own, but this is a script for you to easily do it yourself. And also the rest of the script that I already mentioned, the monolith script of Server Hub underutilized has a bunch of checks on it, and the max memory recommendation script, and the ultimate compression savings estimation script. And I think that's about it. And now is the time for questions.
Awesome. So as Eitan just said, be sure to put your comments in there. We have actually no questions queued up. Every question we've had so far has already been answered, which is a good thing.